Synthetic substitution is commonly used to evaluate functions. Here I have the graph of f of x equals x cubed minus 2x minus 4. In order to evaluate this function at x is equal to negative 1, I'm going to start by writing the coefficients of each term. 1 times x to the third plus 0 times x squared minus 2x minus 4, and I'll put my negative 1 outside the bracket. Bringing down the 1, I then multiply by negative 1 to get negative 1, combining with 0, and then multiplying with negative 1 again, I get positive 1. Combining with negative 2, and then multiplying by negative 1 one more time, I get positive 1. Finally, negative 4 plus 1 is negative 3. So I have found that the function evaluated at x equals negative 1 is equal to negative 3. And that point would be right about here. I can also try to evaluate the same function for positive 1, where x is positive 1. So I'll go ahead and set up my synthetic substitution with a positive 1 outside. When I start to go through the algorithm, I find that the function evaluated at x equals positive 1 is equal to negative 5. So we can write that as f of 1 is equal to negative 5, and we can plot that point on the curve. It would be right about there. So in summary, we found that functions can be quickly evaluated for a given value of x using synthetic substitution. We could graph this in a chart or table, such as the first column is x, where we had x was negative 1 and positive 1, and we found that f of x was then negative 3 or negative 5. Or we could use function notation instead. F of negative 1 is equal to negative 3. F of positive 1 is equal to negative 5.